Welcome everybody to the last of the pre-flight series of IPI conference. Today we have two speakers and we will start with Professor Wim Deferme from the University of Hasselt, who will talk about the PAPERONICS project.
Okay, thanks a lot, Peter and Mashi, for organizing this interesting concept of pre-flight before a conference. Let me share my screen and start the presentation. I think you now can see the slides. So, well, let me introduce indeed the PAPERONICS project at the conference 18th and 19th of May, the industrial print integration on the 19th of May. We have a session about the PAPERONICS project where people from industry, but also research partners will tell a bit more about what we did in the PAPERONICS project, because PAPERONICS project was a project, a Cornet project, where we had these research partners. So from Flanders, IMOMEC, IMEC, KU Leuven, and then from Germany, we had IVLV, Fraunhofer, the University of Chemnitz, and PTS. And so together we investigated during 2 years what you can do with printing on fiber-based substrates, paper, for example, cardboard. And we had a consortium of more than 33 companies that followed the project and give their input. So what we try to do is building a platform for printed or hybrid electronics applications on these fiber-based substrates. And of course, if you talk about this, you can think about a lot of concepts, printed electronics concept that you can bring in. And of course, we aim to have smart systems containing, for example, sensing, also interaction, energy harvesting and energy storage. But also if you do sensing, data storage and data transfer. So this all is our concepts that we try to integrate onto the fiber-based base material, looking at the integration technology and of course the applications. And so for the first step that you would like to do, of course, is look at the substrates itself and see what is the status up to date. So this is before we started the project. If you look at labeling, for example, you have an RFID chip and an antenna which is labeled, nothing really printed. If you look at PAPERONICS, what we try to do is looking at the RFID chip and maybe some signage and energy storage, which is on labels, but then looking at printing, for example, antennas, interconnects, sensors. But of course, in future, all printed would be ideal. But of course, that's maybe something which is difficult feasible. So that's why we also not put only printed electronics, but also hybrid electronics in this project. Another issue that we tried to look at in the project was not only let's say the research part, but also how companies interact in this interesting paper-based printed electronics story. And what you see of today is that you have a lot of companies that work together or need to work together in the complete value chain. What we tried to work on in this project is looking at packaging companies. What can they do, for example, doing the label conversion and the integration, the package integration, what they already do, but also looking at, for example, can they manufacture some printed electronics components and can they assemble the tag? But in future, of course, one of the ideas is to bring everything in one company. Okay, so let me quickly introduce two demonstrators that we developed. The first one is a customer relationship package. And the idea there is to print some devices such that in the end, you can follow a package in its logistic chain. So these are the components that we used. It's the package. We use an antenna and an RFID IC to start simple. So this is the first demonstrator. You start from a simple concept. The RFID IC, this is something that is developed with IMEC on a thin film. And then the antenna, this is something that we print and we try different printing steps. We will tell more about that at the conference itself. And of course, the first step if you start printing is investigating how the ink, the functional ink, also the printing technique fits to the fiber-based substrate. So that's the first step that we did in the project, looking at those three components and see how they interact with each other. We started with a lot of substrates, more than 70 substrates that we assembled from a lot of different companies, like you can see here. And then we start investigating the properties of the substrate itself, but also the properties of the ink when it was deposited onto the substrate. So in this pre-flight, I only focus on screen printing. In the end, we use different printing techniques as well, also a few from the companies, to test if that works on the substrates, on the fiber-based substrates. Here we only use screen printing, and then for the inks we used an ink from Agfa, the Orgacon ink, and then an ink from Henkel, a Loctite ink, and then we looked at the interaction on the substrate. If you look at the properties from the paper or from the fiber-based substrates only, you of course have the surface roughness, which affects the wettability of the substrate. Also, the permeability was very important. That links to the absorption of the ink onto the or into the substrate. The surface energy is something that we measured, affecting the wettability and the absorption of the substrate. And then, of course, the heterogeneity of the substrate or the chemical composition, and many more of these characteristics were analyzed in the project. If you look at the print performance, of course, the surface roughness and the wetting and penetration of the ink is very crucial. Generally, they say that you need very smooth surfaces, and a lot of applications or solutions use a coating on top of the fiber-based substrate and then deposit the ink. And of course, this is something that, in view of going to low-cost applications, is something that we tried to compare and to see if it could be done without this extra coating. So that's something that we investigated. If you look at the application on top of the substrate, so once these substrates are characterized, you come up with the best substrates, the best inks, and the best printing techniques. This is something that we keep for the live conference. Then of course you go towards the printing of the devices, and here we print RFID antennas. We have a working frequency of 13.56 megahertz, and then of course some requisites that we needed, the resistance range and the inductance range, to be operational with the RFID provided by IMEC. We had a design, let's say a design phase, where we looked at the number of coils or the number of turns, the width of the tracks, and in the end, also, for example, the line width, the interspacing between them, the total area, and that was investigated onto the substrate. We evaluated these antennas for their series resistance and their inductance, like I mentioned, but then also connecting the chip, looking at the resonance frequency and the bandwidth, and then also really testing the functionality of the RFID by using a reader for extracting a tag code. And this is the final result on a fiber-based substrates, where we have the antenna, where we have the RFID chip connected to it, using an IQ bond from Roartis, which was one of the companies in the project, and the final integration was done by Quad Industries. And this is one of the designs that show to be functional, show to be doing the job that we were planning to do. And then together with the colleagues here at Hasselt University in packaging technology, and together with Ropak, we developed a box, like you can see here, that is foldable, but that is also very strong. So we did some tests to see what is the effect of impact and drop testing, box compression, vibration testing, and so on, to see if this box can be used for multiple times, because that was the idea of the smart box for e-logistics, that you have a label inside with the antenna and the RFID, and that this can sense or can have data that knows where the package has to go. But then, of course, once the package is delivered and the goods which are in the package are unpacked, you can resend the box, for example, by some logistic partner can have the box back and can reuse it by just overwriting the data in the RFID for a new customer, for example. So that was the idea. Sorry, a bit too fast. That was the idea, and of course, with some partner companies in the user committee of this project, we also developed some software, and we have a nice demonstrator of this box, which I will show for sure on the 19th of May in Germany. And then let's take one step further. I skip demo 2. I go directly to demo 3 because this builds on top of the antenna RFID ID, which is a temperature sensor package. So what we do here, we start again with the antenna and the chip from IMEC, but we connect now a temperature indicator and some interconnections to the antenna to make a temperature threshold indicator. So the printing of the antenna and the IC, the passive RFID tag, we have already discussed in demo 1. But then, of course, you also have the interconnection and the temperature indicator that we focused on printing. So that's the next step, the temperature threshold indicator. And for this, we printed this design. So we have the antenna again, we have the chip here, and then you have the interconnection. And here you have an interdigit electrode. And this interdigit electrode, or let's say the complete stack here, is screen printed. Yeah. And then what we did here is coating this interdigit electrode with an emeraldine base coating. So, and this base coating is a coating that is, let's say, non-conductive. But at the moment that a specific temperature is reached, you can create a release of a specific acid. That's the idea that we had here, the acid release, such that this emeraldine coating becomes conductive. And then, of course, you have an interconnection, and the antenna RFID system will sense that temperature threshold is overcome. So that's the idea of the complete design. And the coating itself is not screen printed, but is ultrasonically spray coated. That's a technology that we also have in the lab, besides screen printing and inkjet printing, for example. This ultrasonic spray coating, how does it work? Well, quickly, you have a syringe in which you have your ink, and the ink can be composed of some solvents with nanoparticles or with a polymer, can be very diverse. The ink formulation is much more, let's say, less stringent than with inkjet printing, because what happens is you bring your ink formulation towards the nozzle plate here, and this nozzle plate that you can see here on the right bottom side, on this nozzle plate, you apply your ink. And by ultrasonically vibrating this ink, you create standing waves and droplets that are generated from these standing waves. And these droplets contain the solvent with the functional material in it, and is brought towards the substrate by using a shroud gas. In our case, we use nitrogen, but this can also be something else. Here you see a small video of the system itself. Let me try to show it. Here you can see, you see the nozzle, you see the shroud gas, and here you see the droplets that are brought towards the substrate and sprayed onto the substrate. And for this application, the coating thickness was not really that crucial, but if we look in organic electronics, something we also do, we need coatings that are around 30 to 40 nanometers, and then this ultrasonic spray coater can do the job in depositing this ultra thin coatings. So for this temperature threshold sensor, we used the antenna design that we had from screen printing, And then here, this printed temperature threshold indicator using the spray coater, the ultrasonic spray coater, to deposit this emeraldine coating. And then looking at a specific resistance change and see if we can sense that with the antenna system and read it out. So what we tried to do is to make a complete stack where you have this interdigit structure, which is screen printed. Then you have your emeraldine based coating. We have some SAFAR PET foils on top to put the nanocapsules and then a barrier coating. And then if the temperature, and that's something that colleagues of mine are working on, if you have a specific nanocapsule, this nanocapsule can contain the acid. And once a specific temperature threshold is overcome, this nanocapsule will open, and then the acid is released through the SAFAR pads onto the emeraldine base, and then transfer it from non-conductive to conductive, such that this interconnection is closed. We didn't go that far, so we are still in the research phase for these nanocapsules, but this is the concept. And then in the end, of course, what you can do here you see the final design with the layer which had already the acid that can, for example, be placed again in a box, such that you can measure if a box which is transported exceeds a specific temperature during transport. I have a short video of how it works, and this is the final design. And of course, because our nanocapsules do not work yet, what we printed here, 3D printed, is a syringe that just flows the acid onto the interdigit structure once the temperature here is increased. So this is demonstrator, a simulation video of this. So what you see here, the temperature is low. We measure temperature is still okay. This is measured with, of course, this RFID IC, and then we change the temperature to high. The acid comes out, and you have a conductive pathway, and that is seen if you take again your RFID reader that your temperature is over the limit. So that's how we showcase that this demonstrator is doing the job, but of course it's not completely finished, as we still work on the nanocapsules. So in the end, I would like to conclude this short presentation by saying that the final conclusions from the PAPERONICS project is that we worked on a simpler supply chain at lower cost, so low-cost paper-based substrates, no coatings, printed devices such as the antennas, and using the RFID chips from IMEC. Process simplification. Also, material consumption is reduced a lot, and also the ease of customization using printing approach in PAPERONICS shows that we can go to an easier customization. So with this, I would like to thank you for listening. Thanks the organizers for giving the chance, and hope to see you on 19th of May in Düsseldorf. Thanks.
Thank you, Wim. Interesting, of course, this project. We knew all about it. You were part of the group. But next up is Dr. Kai Keller from Notion Systems, and he will give us the next presentation.
Yeah, thank you very much. Thank you, Wim, for this very nice presentation. I hope that I can be at least as interesting, or it's not as technical, it's not as detailed, but I hope that that is still like what I have to present. Okay, and thanks to the organizers, of course, for the possibility for this pre-flight session. I'm very happy to give a short introduction about what I think is the basics of or what the basics of our company is, and the basics of functional printing. And yeah, so an outline of my talk. I will start out with a short motivation. Then what is inkjet? For those, I think I don't have to explain to Wim, but maybe there are some few in the audience that don't know what inkjet is, or at least I can say a few things about our viewpoint. The application space, the parameter space, I will say a few words about Notion systems and give some application examples. And of course, I'll have an answer and outlook to the talk I will give to the presentation at the IPI conference that will be on 18th of May in Düsseldorf. Okay, so as a start, I know you probably know the Gartner hype cycle and have seen it in a lot of presentations before. Nevertheless, it's a good view, good motivation for my talk about what I want to talk here. So if you go to, so this is a cycle that this company Gartner said any new technology would go through over time. So if there's a new technology, there's a trigger. There are some expectations from the public and some time scale that there are different phases that this technology will go through over time. So you will have for any new technology some inflated expectations that never can be met. Then there will be a disillusionment, some enlightenment. And in the end, you'll reach, hopefully, you reach productivity. Sometimes it's called a productivity plateau. I hope it's not a plateau, but there's a slight slope that you can expect more from a technology. The further you go, the more, the longer you develop in such a technology. But it's not only technology that goes through these phases, but it's also in client interaction that the client goes through these phases. It's very important in business development that you understand where the client is. Is he wowed by the technology that you want to provide? Is he in a phase where he has very high expectations that you will never be able to meet? Is he already in disillusionment and thinks everything you tell him is bullshit and will never work? Is he already in a phase that, where he's over this disillusionment, or is he already quite an expert and understands what you want or what you can provide? So as there are many companies in this online session and in IPI. That provide technology. So the question, or provide very good technology, the question is what's our role in all this hype cycle stuff? And I think our role is to pull this to explain where we are and to pull this hype cycle a bit further to the right by innovation and by explanation, by explaining about our technology to the clients, to the ones who want to realize the applications. And we have to be honest with them, and by that, hopefully we will get a few less vows and a few less bullshit, a little less bullshit, but then we'll in the end we'll get more happy clients or a more realistic viewpoint of the whole technology. So what I very often do, or my favorite question in achieving that, is since we are a company providing inkjet technology to the market, my favorite question is really asking the client, why would you want to do it with inkjet? Is there any more sensible, more or other way in achieving what you want to achieve? And it's a good way to start such a conversation to see where your client is. So very often we come to the point that we have to talk about what inkjet actually is, and I want to just in one slide explain you, in 1-2 slides, explain you what our viewpoint of inkjet is. First of all, inkjet is a means to eject picoliter droplets of a fluid out of a jetting nozzle. It is to it is very fast, up to 100,000 droplets per second per nozzle, and it's highly parallel. Yeah. So we typically in one system we have up more than 10,000 nozzles per print unit at a distance of 20 to 200 micron nozzle to nozzle. So this provides you with a tool that detects 1 billion droplets per second. So if you have such a tool, you can apply layers. And well, you all know how it's done. You have this printhead going over the substrate, and then you can code, you can structure, you can have both coded areas and structured areas in the same print layer. And yeah, and now the question is, what do you put down? Yeah, or what can you? So what are these droplets? Yeah, it very often it's color. Yeah, but it can be any function as well. Yeah. And what we do at Notion Systems is we are putting down functions. So we are supplying to the semicon and PCB industries and display industries, and we try to put down functions with that with inkjet. So which functions can we, or which functionalities can we put down as layers? And it can be anything in electronics, like conductives or dielectric layers. In optics, reflecting, diffracting, or blocking layers. In we can put on active layers like lighting layers or energy conversion layers or sensor some sensor layers. Resists like etching, plating, or vacuum deposition resists. We can print adhesives or adhesives or encapsulation layers for display, semicon, and packaging, or displays and semicon packaging area. And last but not least, we can print optics and high precision 3D parts. Yeah. So question is, what the parameter space, and I'm very happy that Wim showed a quite similar triangle. There's we call it the inkjet triangle. There's the ink, the printhead, and the substrate that will make up a that are the main components of a working inkjet process or working printing process. And of course, there are limitations. I don't want to go into detail, but since there are many technology partners here in this conference, I mean, this is where innovation takes place. Yeah. So by pushing the limits in viscosity, or by pushing the limits in drop volume or number of nozzles and stuff like that, in how we actuate the printheads, how we print, that's where the innovation takes place, where new applications can be realized. Yeah, and I'm very happy that there are a lot of companies working on that. Okay, so what does our company do? We want to be the ones who bring this innovation or our own innovation, but also the innovation of our partners to the market, to the different markets, and not only graphical markets, but also the electronics markets. Yeah. So we do this since 2012. We were founded in 2012, and we see ourselves as one of the leading suppliers of industrial inkjet printing systems for functional materials. Our platforms are already used to produce electronic displays, printed circuit boards, semiconductor components, as well as high precision optical 3D parts. So we have quite some expertise in bringing precise inkjet systems to clients and scaling up digital printing processes from laboratory to industrial production. I don't want to go into details for what happened since 2012. There are a lot of installations. Since last year, we are part of a bigger group called the RSPG Advanced Manufacturing Technologies Group. It's a cluster of companies with one one investor that are, say, providing technology around semicon to the semicon and electronics industries. There are companies like Heidelberg Instruments or Series who are directly supplying semicon industries, and we are, so Notion Systems is the additive manufacturing part in this cluster. There's, in any introduction to a company, there's a world map. That's our world map. So Notion Systems exists exactly once in Schwetzingen, which is close to Heidelberg in Germany. And of course, we have partners, our agents and service providers with a focus in Asia. Europe is mainly done by ourselves, and for North America, of course. Okay, application examples. What have we realized so far? These are some pictures of the systems that we or some example pictures of the systems that are in field. In display industry, very often in OLED manufacturing, you need to care about the OLED materials, which are apt to or they don't like oxygen or moisture too much. So you have to print in a nitrogen atmosphere. So we partnered with M. Brown to provide a system with such a glove box on top. And we realized applications like RGB printing, encapsulation, light blocking, switching, and guiding layers for display industry. In electronics, we have a system for solder mask printing. We realized a new process for solder mask printing, replacing a lot of the process steps that are that have to be taken today in production to apply a solder mask to a PCB. We also have systems for edge resist printing in field or for very specialized systems for printing conductors, dielectrics, or active layers for the electronics production. In the semiconductor industry, it's very important to have a very clean environment in your platform. That's why we have this laminar flow box for the semicon applications, for the semicon platform. And applications are photoresist printing, sensor active inks, chip packaging, dielectrics, conductives, resist adhesives. I have to say, to print the chip is not something that is within our reach. So I'm very happy to discuss or to hear more about the ideas of Wim to print semicon chips completely. Resolution for inkjet is much too coarse to go in this area, but there's a lot, as you see, there are a lot of applications in the resolution area of inkjet, also to make semicon production more efficient. Last but not least, 3D printing. There are a lot of 3D printers or 3D printing technologies in field, and they're mainly adopted in rapid prototyping and this kind of stuff today still. One of the main reasons to go to inkjet is that you can combine different for 3D printing is that you can combine different materials with each other, and we use that to realize applications in what we call advanced optics, so combining different optical properties in the same lens. Also making precision parts and providing additive manufacturing solutions in what we call hybrid manufacturing, so printing directly onto onto some PCBs or LEDs or these kind of things to integrate additive manufacturing in the process chain of an electronics product. We also do application development with our partners. This is a service that we provide from laboratory to really 24/7 production. We start very often, or it depends where the client is. We start with printer selection support, ink selection support, compatibility tests, print process development, pre and post processing support, process training, and we also, if it's monitored by our partners and clients, we do on-site process support. With doing all that, we focus on the printing process itself. So we know how to print, how to generate droplets. We don't know how to manufacture an OLED or stuff like that. So this is completely left to the client, but we can add our value by providing our know-how in inkjet printing. So back to the question from the beginning, why would you want to do inkjet? And to give a quick answer and an outlook to the conference presentation I will give at the conference on 18th of May. So if we go across all the applications that I only showed you a few of in this presentation, or only give you an overview, these are the reasons why people usually invest into such a technology, or at least for the platforms that we have. We do direct digital printing, and here are the more technical reasons, which are we print only where required. We can print multiple materials, print in multiple layers, doing something like 3D printing, and do wet and wet processing, so printing multiple functionalities at the same time. The reason why say less technical people invest into such a technology are the reasons on the left-hand side here, which are direct consequences of what I've already shown you. It's mainly the faster turnaround, so we have less material waste, less process steps, a higher yield. Because we have less process steps, we have a higher yield, and lower energy consumption. Just to put one digit there, so one of our early clients investing into the solder mask process is that's something I want to share. They made a calculation of what is the power consumption, or the earnings in power consumption that they have by replacing one of their production lines with one of our systems, and it's a 6-digit euro number that they save each year just by reducing the power consumption in that process. So it makes sense to invest into inkjet and additive manufacturing in electronics, and also in order to make the whole industry greener, to help it reach their goals in becoming a greener and more sustainable industry. I'll go into detail. So for the talk at the main conference in May, I'll go into more detail regarding the reasons why you would want to go into additive manufacturing. I'll take one of the examples of the application that we have, and go through the digits and through the reasons, what are the different processes involved, and why additive manufacturing makes sense in that case. So thank you very much for your attention, and I'm up for questions if there are any.
Yes, thank you, Kai. At the moment, I haven't seen any, neither for any of both of you, but I have a global question maybe, and it comes maybe from first for you, Kai. Where is still the bottleneck for production? Is it with the type of companies that want to invest, or is it like Wim indicated in the PAPERONICS project, that we go in multiple levels, combining printing more than ever before, like additive manufacturing, closer to label industry, to other production facilities that want to involve printing?
Yeah. So yeah, maybe I answer first. Thank you, Peter, for this question. So first of all, it is adopted in production already. It's hard for us to speak about production applications because they are still very new, and our clients very often want to have this publicity for the processes that they developed jointly with us. But just to make a few digits there, we have today we have roughly 60 systems in field realizing 40 different applications in production. So and they're very diverse. Yeah. So it's all printing, but it's in different process steps in production. So it is in production. It's not something that it's not there yet. Yeah.
And Wim, would you like to add something?
Well, I think that what Kai says is correct. If you look, maybe that's more from my perspective. If you look at the different technologies that are out there, screen printing, inkjet printing, spray coating, it all depends on the final application that you would like to have, and of course on the let's say the series production that you would like to do. If you have only one or a few pieces that you need, inkjet printing is very interesting because you digitally can adapt the design you want to do. If you have millions of those and it works with screen printing, then screen printing is maybe the way forward. Of course, it also depends on the final layer thickness, for example. With inkjet printing, thicknesses typically around a few hundreds of nanometers, where with screen printing you go to a few microns in thickness. Line width is comparable, let's say. So it all depends on the end application, let's say.
So actually, our conference, Industrial Print Integration, is the right way to go to integrate print technologies in production to save, like Kai showed, lots of energy, optimizing in waste, flexibility, higher yields. So it has definitely a bright future.
I'm quite sure, yeah.
Maybe if there are no questions coming from the participants, this is an ideal wrap up to invite people to come, of course, to the Industrial Print Integration Conference. But here you also see the contact possibilities if you want to get more information either from Wim or Kai on their subjects. But of course, you can meet them in person during the conference, which is 18th and 19th of May in Neuss, Düsseldorf in Germany. Also, more details on all the presentations are on the conference website. And I think I would like to thank not only today Kai and Wim for their presentations, but also in all previous sessions and previous pre-flight sessions, all the speakers, and of course, everyone who is participating in the IPI conference in almost a month. So thank you, everybody, also the participants here, and have a nice afternoon, and see you all in Neuss for the conference.